is the first time we are doing a tech day at Simoldes, we want to share with the rest of you that are Simoldes but are not here in Portugal with us what we do internally. We have taken this opportunity, which is the finalization of the NANO SIM project, to do the first tech day, but there will be others, namely regarding only the additive manufacturing and other items that will come up in the meantime. So first of all, let me introduce to you who don't still know him. He's very well known in Simoldes, but maybe someone maybe outside of Simoldes not. This is Júlio Grilo. He's the Director of Research and Innovation for Simoldes. Júlio.
Hello, good morning to all. My name is Júlio Grilo and I am Research and Innovation at Simoldes Group. So today we deploy a new research and innovation project at Simoldes Group, where we have added new advanced technologies and also materials that will be introduced by the Simoldes team and also the ESA team. So please let me thank to all the people from Simoldes that participated in this project, to João Vieira, Ana Rita and Jaime Monteiro, and also to thank to Aveiro University their participation and their researches. See you.
Hello everyone, my name is Ana Rita Frias and I'm here just to briefly present you the main goals of the NANO SIM project. Well, product-wise, the goals of the project were to develop new metal matrix nanocomposite materials for the production of new molding components with improved mechanical and thermal properties. Also, the development of new polymer matrix nanocomposite materials for new thermoplastic injected parts with lightweight and improved mechanical properties. The project also aimed to innovate in the process of the additive manufacturing, which resulted in the construction of this laboratory where we now stand that will be presented by my colleague João Vieira, and thank you very much.
Hello, I am João Vieira, the additive manufacturing responsible. We have the additive manufacturing SLM equipment, but one of the most important elements of this project is the team, the additive manufacturing team, myself and Luís Oliveira and Gustavo Pereira. Luís is the data and simulation engineer and Gustavo is the machine operator and the model treatment. It's here that we analyze your proposals, your requests for additive manufacturing inserts and the components. It's very important, very soon as possible, you ask us for questions for the possibility of build inserts and the application of the technology, because maximum until the simulation, rheology simulation and the cooling simulation, you have the hotspots defined and identified, so it's very important in this phase of the project, maximum, you send us some requests to analyze the possibility of the application of the technology. So we have also here a place for investigators from the university that regularly are here for the project, and I will present you one of the investigators of this project, Daniel Ferreira, that is the person that investigates the nanocomposites with the metal matrix and the nanoparticles. Daniel Ferreira.
Hello everyone. Now in English, I will explain the part of the development of nanocomposite materials for the mold industry using additive manufacturing here in Simoldes. In this table we can see all the steps of the process. The process starts with powders, steel powder and a reinforced component. This is tungsten carbide to reinforce the steel. And the second step was to perform a ball milling in this vessel with metallic balls. And the manufacturing step included is reduced build volume in our Rennie Shaw SLM equipment. We tested a lot of specimens to characterize our specimens or quality. Here we can see the specimens that we produced, tensile specimens and impact specimens. And the final step of this process was to develop an insert. We developed this insert made of different materials, different reinforced materials. This is not only steel, this is steel reinforced with nanoparticles, with a very good wear resistance and mechanical properties. This is very good to increase the life of the molds. Finally, I want to present the quality control of the powders. These are two equipments to control the quality of the powders. Here we have this half funnel to control the flowability of the powders, and here we can see a tap density equipment that belongs to the characterization step.
Hello again. Continuing with this instrumentation for the characterization of the powders, we have also here the characterization of the porosity. You can see we can also, with control of parameters, develop some porosity, regulating the density of the steel, and we can apply this for venting of the molds or for vacuum situations. There you can see other applications. In this case, conformal cooling for eliminate the formation. You can see the formation here and no deformation here. Deformation, no deformation with conformal cooling, in this case slides. And don't forget, in this technology, it's better we use filters in the water circuits. Everyone knows what kind of water they have in the plants, so depending of that, you can use a more efficient filter, even with a flow sensor, or a smaller filter, you see, with 2000 micron net for filtering the water. But it's very important to use this when we use this technology. And here we can see a typical conformal cooling insert with 4 circuitries parallel to every wall, where we have a rib here, here, and here. So 4 parallel circuits, very efficient, very optimized. Here we have a challenge for the machine, because in general this dimension is bigger than the machine, but with some optimization of the insert, we build it, and you can see it in the project roll-ups. So we have other applications here that we are studying and applying, like porosity again. Porosity, an ejector with porosity, you can see. The venting is through this hole after the #7 area. And other applications like permutators, or we can lattice applications for reducing volume. We can reduce volume also with just eliminate the material. And now I will present you Luisa Lima, that is the investigator from the Aveiro University that work about nanocomposites with thermoplastic and nanoparticles. Luisa Lima.
Hello again. So regarding the development of new thermoplastic materials reinforced with the graphene nanoplastics, for these we used polypropylene polymer from Simoldes Tech of Czech Republic. The nanoplatelets used was nanoplatelets of graphene from XP Science. We were using also 3 different compactalizer agents to improve the interaction between matrix and nanoplatelets. The technology deployed was a Brabender type mixer machining and a extruder to obtain these nanocomposites. So here we have a sample of nanocomposites granulated. We used also 2 injection machines. The first one to obtain these samples to mechanical tests. And here we have 3 samples injected here. This one is polypropylene fuel. This another one is a part injected with nanocomposites developed with 1% of graphene. And here is a sample of polypropylene reinforced with 40% of glass fiber. The difference between these parts is the weight reduction. With nanocomposites, we was obtained a reduction of 27% weight reduction. Regarding the mechanical properties, our nanocomposites achieve improvement in flexural strength in about 70%, and improved also the stiffness in 30% compared with the pure matrix. So now, Professor Martin will give some words about the project.
Hello, Martin Oliveira. We are here in this project, and I will try to summarize and give a different point of view regarding the developments that we have achieved with this project. First of all, we want to give some new tools for the Simoldes groups, namely regarding the development of new material solution from the point of view of the tools, working with additive manufacturing nanoparticles, but also from the point of view of the thermoplastic materials that you can join with these kinds of molds with these inserts, and you can get new solution in terms of performance of the mold, not just regarding the nanoparticles that we put inside the inserts, as also the nanoparticles that we put in the thermoplastic nanocomposites. So we have here some new solutions and some new horizons for the Simoldes group, because we are now developing new raw materials, let's say that way, and give some innovation capacity to the Simoldes group. So it is a challenge for all of you to look for more information regarding this project, as well as discuss some ideas that you have in the future and that can be good for the growing of Simoldes groups. For me, it was a pleasure to be here, and now I will pass the word to Luis. He's an engineer that is working with the Renishaw 500 key, that is the additive manufacturing equipment that we use in this project. Have a good day, and don't forget to come to Portugal. The sun is always shining for you. Thank you.
Hello. As Professor Martinho said, we have here Renishaw 500 cube. Don't let the size fool you, because it has 4 powerful lasers that can be as 4 times faster than one laser machine. It has automatic powder recirculation and a patented vacuum atmosphere, so we can build our parts without defects. So with this, I end my presentation, and I will pass to Sonia. Thank you.
Hi, hello again, everybody. So thank you so much for watching, for spending some of your time with us, getting to know a little bit more of who Simoldes is. Stay tuned for the next Tech Days. We will have one specific about additive manufacturing in tooling, so SLM, which is the technique that we have in-house. In case you have any questions regarding this or the subjects of the matter, please send us an email at marketing@simoldes.pt.